evening. So I'm still slowly trying to figure out why I'm here. Just arriving here, I mean, this is unprepared content. It reminds me two things about being young and being a student. So when you're young, when you're thirsty, you drink bubble tea, although instead of water. Although that's not exactly what you need, it make a very slight difference for you. Trust me, it make a huge difference. You just don't know, right? This is part of being young. Drink water, drink bubble tea. I mean, it solves your problem. It gives you a little bit of other things. Doesn't matter. I mean, for me, it matters. And the other thing is, also remind me another thing. So especially watching just now the functional programming stuff. A concept called divide and conquer. I think most of you are CS student, right? So you should understand what is divide and conquer, right? What does it stand for? What do you divide? So divide and conquer is a metaphor from probably the Roman time, right? When you're attacking your enemy, right? They're too strong. You want to divide them so that you can conquer them, right? So when you're a student, okay, you're given a problem. The entire problem is your enemy, right? There's no friend. Your friend is the mathematical tool you discovered or given by the teacher, okay? And then you use it to divide the problem into smaller problems and conquer them. They're all enemy. But when you are in an industry, the story is very different, okay? You build a product, right? The problem you are solving is your enemy, but the product is your friend. The company need that product to solve the next problem, right? And if you divide them, so divide is to weaken. If you divide them, okay, you are weaken your product. You will have less advantage to use it to solve your next problem. Unfortunately, people after their education, when they join the industry, they only remember divide and conquer, divide and conquer. They don't remember which one to divide, right? They never learn how to foster this friend. Okay, so that you can build a product that is sustainable. I think it's still related to the topic I'm going to share. I need to accelerate a bit because I tend to talk a lot. I'm going to talk about a tool I built 20 years ago. It's called Lizard. It's a static analyzer. I'll explain what does it do soon. So very briefly about myself, I'm Terry. I work in a company called Audi. I'm a programmer, so I think I'm a professional programmer that builds products. I'm also a father. This is my son, like 10 years ago. So is the boy happy or not happy? Not happy, because do you know what it's holding? It's a coffee grinder. So it grinds bean into powder. So although it's a pretty easy thing for an adult, it's quite challenging for a boy. I didn't make the boy to do it. He saw me rotating. Looks fun, and he wanted to do it, but it's still challenging for a 3-year-old. Next moment, now happy or not happy? How come the boy suddenly becomes stronger? He figured out, although it's very hard to rotate this way, but it's much easier the other way, right? So this tells part of the human nature, right? People want to go fast. It doesn't matter the direction, right? So you just want to go very fast, even if it's the wrong direction, even if it doesn't produce what you want. This is me. Am I happy or not happy in the picture? So I look pretty happy, right? So I want to use this picture to explain who am I. I'm a software developer. So this is a software developer, by the way, not a hardware developer. I hate hardware. And this is a JavaScript conference in Singapore. And we were coding on a Raspberry Pi to build something, build some robots. I don't know anything about robots. Our idea is we have this LED stripe, right? We just program it so that the light can form something, and we just swing. And then you will see our plan was to show the time. You just swing it at a certain frequency, and then you should see it. That was a plan. So I was demoing that. And this is the next moment. Happy or not happy? It didn't work. Yeah, so yeah, I only know a little bit about building software, not anything else. Okay. So the story of Lizard, very briefly, because I don't really want to talk about the tool itself or the thing is analyzing so much. I started not 2007. It's 20. I think it's 2005. At that time, I was working in Nokia. Not the mobile phone Nokia, by the way. We are making the 3G network at that time. Okay, the network part of Nokia, and we use C and C++. I think you should know what is a continuous integration server, right? It's when you are writing code, okay, you submit, and then there's a centralized server building it, testing against it, and then to make sure you're not making mistake. So many people are contributing to the same repository, and then there's a centralized CI server somewhere. It's a standard practice these days. But 20 years ago, it wasn't so standardized, but we were doing that. Okay, so we commit and push very frequently, and then so we build very frequently. There was and then not only compiling, building, and running tests, we're also using static analyzers to analyze whether the code is too complicated. If the code is too complicated, our CI will fail. And then reminds the developer, so this code you make is so complicated, please simplify it. Okay, otherwise it wouldn't pass the CI. But the embarrassing situation is the tool we use is a commercial tool. Although the static analyzer only reads your code, just like a compiler reads your code and try to parse it, to try to understand whether how many tokens are there, how many lines of code, like how complicated it is. So it's quite simple work, but because it's a commercial tool, you need to pay for it. And then to validate that you paid for it, it will need to first connect to the network to a license server to make sure your copy of software has enough license. So the embarrassing thing is, more than 80% of the CI failures because we just don't have enough license to run things in parallel. Okay, so this continues for 2 years. So we started like 2003, and then until 2005, I had enough of this shame. Okay, so I decided to do something. And then at the time, I learned the Python programming language. I want to use Python to build something anyways, so I started to build this project to do the analyzing. It stands for, so the tool is called HFCCA. The HF stands for header free. If you know C or C++, do people still learn C or C++ these days? Okay, I'm sorry for you. Yeah. So you need a header, right? So because a lot of tools, you need a preprocessor. So the code might not be exactly what you were looking at, because based on the macros, the code might turn out to be very different. So you need to parse the header as well. So, but what we care is not how exactly the code is, how complicated exactly the code is. What we care is how complicated it looks like. Okay, when the people read it, how complicated it is, how easy it is to understand. So we should just ignore the header. So that's our plan. We just pass the source code and ignore the header. That's the idea. Very briefly about what is cyclomatic complexity. It's just pretty simple. It measures at the function level or method level if you're using Java. So it measures how complicated a method or a function is. If a function has no condition in it, there's no if, okay, or no logic thing, the complexity is 1. So there's no 0. Just the smallest number is 1. But if you have one if or one for loop, there's always a condition in a for loop. It just add by 1. Okay, even for parallel conditions or nested conditions, it always just add 1. Okay, the logic behind the cyclomatic complexity is if you have too many conditions in a function, it will be very complicated exponentially to validate the correctness of this function. So if it goes beyond the number, mathematically, you won't be able to provide enough proof for the correctness of this function. Therefore, there's a bug, and it's harder for people to understand. So if you put those logic into smaller packages, means smaller functions, you distribute the complexity to more functions. That's what it does. So what is the cyclomatic complexity here? So by default, there's 1, and there's 1 if condition, 2 now, and there's another if condition, 3 now. That's it. That's it. Else doesn't count. Every if has an else, right? It's just some of them are empty. And so it's a command line tool. If you run it, it produces things like this. It has a number of lines of code, the cyclomatic complexity, how many tokens, how many parameters, and then it gives warning if there's function that is too complicated. That's what it does. Okay. One open question. I don't have an opinion on this. Because things like the tool I built, okay. By the way, the tool is mildly popular. It's used in many places like Nokia, Ericsson, like my old telecommunication companies, and also used by organizations like CERN. But then the tool, the things I'm measuring, is it still relevant today? Well, that's a question. It's honestly just an open question. I don't know. Because it measures how complicated it is based on the human cognitive limitation. Not entirely true, but most of the so-called complexity, it means is easy for people to handle. So which means given the limited cognitive ability of human being, how easy it is. But we all know that AI actually has quite different cognitive range. So these days, AI also reads and writes code, so it is still relevant in the near future. I would like to think it is still, but I don't know. I'm also open to different things. Do you know what is that? On the left. What the girl is doing? She's doing a code review, right? Right. So, as I mentioned, I built a tool 20 years ago, and during these 20 years, by the way, Lizard as a cyclomatic complexity analyzing tool doesn't only support C and C++. It supports most of the language. Actually, it supports all the programming language I know. Not exactly true, okay? It doesn't support APL. And what is that? Set? Is it called set? the previous programming language? Yeah, I could do that. But anyways, when I started, there's no Golang yet. There's no Kotlin. There's a lot of R. A lot of programming languages haven't been invented yet. But as they emerge, I just continuously add support for those languages. And then new languages features keep adding, especially TypeScript, JavaScript, they keep changing. And then there was bugs, and people keep reporting bugs, and I was fixing that. And after 20 years, until today, I'm still maintaining this project. And there's a very important concept called cost of change. I can proudly say that the cost of change today to this project is not a huge project, by the way. It's no much difference comparing to it was 20 years ago. Okay, and why? I just make a long answer very short because of the test coverage. Okay, it has automated tests. I'm trying to explain and sell this idea to you in 3 parts. Okay, 2 main parts and 1 less important part. Let me try this part. I hope I don't lose all of you after introducing this. This is not very easy to understand. I will try it for maximum 5 minutes. If it doesn't work, I will give up. Okay. Because I think I could explain the other concepts still. This thing is called jidoka. Jidoka is, or in Japanese, is pronounced jidoka. it's a Japanese term. I think there might be Mandarin speakers. It's called 自动化. Same meaning. So if you understand what is 自动化, it's the same meaning as 自動化. It's everyday word in Japanese. Okay. However, the concept comes from TPS, the Toyota production system, invented almost a century, since a century ago. But except I mean, Japanese people like to confuse people a lot. Except that they actually write it very differently. So the bottom one is the jidoka. I think it stands for automation. Okay, and then they use a different kanji in the middle. Okay, and the true meaning is their jidoka. If you tell this to a regular everyday Japanese, they will get very confused already because jidoka is jidoka, right? And so it means, how do you pronounce that, by the way? No, there's two ways of pronouncing it. You could say autonomation or automation, okay? I'll tell the story and then you decide what to pronounce. So let's go back to almost a century ago. It was the 1930s, okay? So before Toyota was called Toyota, it was called Toyota. It doesn't make car, it make the looming machines, the fabricating machines, and use it to make cloth, okay? They had a great invention which revolutionized the industry since then, okay? And then the idea they create changed all the manufacturing industry until today. Their great invention is, you see, a looming machine is this machine that can automatically produce cloth, okay? It has these vertical strings, threads, and also there is a horizontal one. There is a thing called shuttle, and just going automatically back and forth to sew, it's not sew, to wave. But the problem is, if the thread is broken, you are producing waste, right? And if you produce waste, it's not only just the cost of material, you also need to send someone to get out the defect, the product. That's also a waste, right? Otherwise, alternatively, as just at the very left image showing, you need someone, sadly, watching the machine all the time. Okay, the great invention of, by the way, this Sakichi Toyoda, the founder of the company, invented the machine that it's a machine that is smart enough to automatically stop working. Right, that's interesting, right? So a machine that can know how to automatically stop change the game a lot, become more productive. Because once the string is detached, or something, other thing that is abnormal, the machine just stop automatically and then refuse to work. Okay, when it stop, first, it's not producing any further waste. Second, there might be alarm, and then a worker can come here and inspect intelligently, and then fix the problem and restart the process. Okay, so this is not only just greatly reduced the workload, it also gave the human intelligence a chance of engagement. By the way, later it's called Kaizen. You probably saw the two kanji in my back in the earlier photo. In the Chinese, it's called Gaisan. So that's the automation. I hope I've explained the concept. In TPS, if you further extend the jidoka conference, the concept, it says if you want to have a full automation, so eventually you think having a worker to inspect the problem and restart the machine is not smart enough. I want automation so that if the string is detached, I want the machine to fix it by itself. Okay, even if you want that, automation, by the way, I already pronounced it the way I prefer, is a necessary step before that. Okay, so you need to provide automation first, so that the machine already have the mechanism to detect the problem, and then if you're still interested, you do the full automation. But you know what chances are, like after you put the automation in place, the interest of really invest so much to invent the full automation reduce dramatically. Okay, so I think if you pronounce it automation, it means that the machine is governing itself. Until a certain point, it cannot. Then I need help. Okay, automation indicates that it is an automation. Yes, it is an automated mechanism. But however, the automation is not contributing for you to make more progress you want. It's the only automation purpose is to automatically stop. Okay, actually, it's to give you trouble. Actually, okay, that's the kind of automation. Typically, typically, a developer, a software programmer, because they are programmers, okay, so their understanding for their profession or their job is to automate things, okay. This is a fundamental misconception, because it's much more important for a developer to use their skill to provide automation rather than automation. If you gave people automation, okay, without automation, you won't be able to create something and make it maintainable for 20 years. So example, okay, I'm not talking about the code automation. I'm talking about counting cyclomatic complexity, okay? We can do this manually, right? We did it. I'm not going to repeat it here. We can do this counting by ourselves. The result is 3. This is manual work. And then we can automate. This is about automation. We can automate it, use Lizard to run against this piece of code. It automatically produces the result of 3. And the problem is, how do I know it produced the right answer? In this case, this is automation, right? How do you know it produced the right answer? Well, someone will have to come back and do it manually, right? But this is just one feature. What if you have 100 features? Well, you have to do this manually 100 times. So now, you know, I think if you have some experience in the industry, you should know that testing a mobile app is actually pretty hard, because they want to be very secure. Okay, so it's not very test friendly. This is one of the pain in the neck that when you're developing a mobile app, the amount of manual regression is a lot of work. Right? If you want to have a bug-free mobile app, it's not easy, I think, until today in the industry. So a lot of manual work. Then here's the automation. Okay, so what is the automation? I hope, okay, at least you can recognize what it is on the very left. If you cannot, there's something fundamentally wrong in the CS education. Okay, what is it? It's a unit test. It's a unit test. A unit test is an automation. But again, the automation is not about automatically continue. It's about automatically stop. You have certain assumption. If your application is correct, this assumption need to stand true. Okay, and then you just write it down. Like for this piece of code, I need to produce the result that first for this piece of code. There should be just one function detected, okay? And the function name need to be exactly complex control. And then the CCN should be 3, okay? Should be 3. And this automation, just like the other physical automation in the production line, if the assumption stands, okay, nobody even know they ever exist. It's transparent. It's not even in the context as long as you're running them. By the way, the safety net is only works when it's actually there, right? So if you have tests and you don't run, that doesn't count. So if you run them, okay, you just produce the result saying everything's okay. You don't really know what was the assumptions and what make the product work. You don't even know. You just know everything was same as before. But if you change something and you run your test, it produces this kind of result. It means your test fail. It means it's like automation or the looming machine detect a broken string. It starts alarm. You broke something. So previously the result is should be 3, but now it's 2. Okay. Now it is an automation again. The automation is about automatic stop. Is this automation also smart enough to fix the bug by itself? Hopefully not, so that we programmers do have a job, okay? So the programmer can come and invest what is the problem, and then fix the problem and continue, okay? So it's the smartness is about protecting the assumption. Whose assumption? So it's the one who wrote the code to solve the problem is their assumption. So if you actually are the one providing the automation to solve the problem, please make sure you leave your automation there to cover them so that it doesn't depend on you. Okay, the spirit is called always believing. Always believing means you always have this mindset that after I gave people this piece of code, I will believe, and then I will not be here, and people can still maintain my code. So quick summary for the first topic about automation or automation. As a programmer, your main this, which is not the only one, by the way, means of doing automation is called automated test. So some of you might know unit test, okay, which I'm going to attack the idea very quickly, very soon. But there's also other kind of like end-to-end very complicated test. So a few points I want to point out. The initial phase, okay, of having an idea, do overall architecture design, and create the initial version of the software is only a but by the way, if you're doing your homework, that's the end of it already, okay. But in the industry, for professional, this is only account for like 1% of the workload. So if it's 1%, it's not even relevant, okay? So the larger part is after that, you need to keep evolving, adding new features on top of it, and then add things automatically, incrementally. That means code is written to be changed, okay? And this part is mostly ignored by people not from the industry. So I will share a little bit about the trendy topic of vibe coding, okay, later. But I am afraid I don't have enough time at that point. So let me mention that already. Vibe coding is focusing on the initial phase of it, okay. So missing the point. And then I hope you can get it. You can use automated tests, or we call it automation, to preserve your knowledge. As you are solving the problem, you learn, my code needs to do this so that it can support my application to solve the problem. So this knowledge now is in your mind. Later, so people will need you as a historian to tell this knowledge. But you don't have to hold the knowledge like that. You can build an automated test to help you to preserve the knowledge. And if you left, people will resort to archaeologists. So another kind of not very easy to understand concept is the context size. When you are solving problem, there is a context, right? So what are the existing solutions, existing code? What are the design and the requirement you need to remember to solve the next new problem, okay? And given we are human that we cannot hold so much things in our short-term memory, we want to reduce the context size. And so automated tests is this thing can just take part of the cognitive load away. You don't need to pay attention to it. Because if it works, like there's thousands of automated tests, it's just run and pass. You don't need to pay attention to them because they will let you know automatically once they break. And furthermore, we want to, because, let me just move on to the next one instead of just talk like this. So that was the previous one about automation. So let's move on to the next thing I want to share, which is before I share what it is, let me very briefly give you a very high level of my understanding of what is a software architecture. This is very, very philosophical and high level. So I get the inspiration from this book, very small book called ABC of Architecture. It's talking about the building architectures. By the way, be careful. If someone trying to explain software architecture using physical buildings, just run, okay? But let me try. I will do this horrible thing to you. Okay. From this book, explain like architecture has three aspects. I'm going to only introduce two of them. The first one is the bottom left. It's called behavior. So what does the software do? What functions, what features does it have? So using the analogy of a building, it might be the flat view. So you look from top down, right? There's a garage, there's a toilet, there's a dining room, there's a bedroom. So this is like what functions, what's the purpose of building it? Okay, the functionality of the building. You can even make, for this example I use, you can make up a story. So like there's a family of four, and they are middle class, and then they have kids going to school, and how they use the space, right? Like that. That's the behavior concern. The other one is the structure. Structure concern of a physical building is mostly, if you look at a blueprint, it will be a blueprint mostly from the front or from the side, because the reason you need a structure is there is physical force trying to bring the building down to the ground. What is that force called? It's called gravity or seismic reason or other natural force. Okay, because of that, in order to provide the functionalities, the behaviors you want to have in the product or in the building, you need a structure. You need a plan how to counter the gravity. Okay, so if you want to, so your building might have a structure that's just enough for the current behavior. Doesn't mean it has enough structure for the future. Okay, so you need to have some free capacity about the future things. So the structure is all about the future. A software is soft. You can change the structure to accommodate more behavior. What is the gravity in software? In making software? I don't know. If I know, I think probably I will get a Nobel Prize or something like that. Okay, by the way, the structure is also called design. Okay, so you design or you structure your code is because you want to have a structure that is strong enough to accommodate the behavior. By the way, when you look at the behavior or the floor plan, do you see the structure? I mean, we hope we don't see, right? Because it's not, the building is about its purpose, its functionality. It's not really about its structure. But unfortunately, you will still see pillars, right? You will still see like things that is from the structure, because we want to minimize them. The last one, which I want to ignore, is the aesthetic appearance. Like you wouldn't confuse, you wouldn't confuse a theme park from a religious building, right? You wouldn't confuse a government building from a school. Government building school probably similar, but depends on its purpose. It has different aesthetic appearance, okay, which is not my concern. Let's come back to to reality. Behavior on the left. How is it represented? It's documented using a specification, which is also, this specification is the kind of specification that is not capable of telling lies, unlike most of the other kind of document. Why is not capable of lying? Because it's also an automated test. If it's lying, it will fail. Okay, so you want to have a specification that won't lie. So this is, and it tests from the very external entry so that it leaves the entire system a black box, okay? On the right side, arguably, you can call that structure. That's how it works internally. It has different parts. Can we just solve everything in one function? If you used to work in Nokia 20 years ago, you should know that's very possible. The largest function I maintained is more than 10,000 lines of code. And I can guarantee it's manually created. It's not generated. Okay. But of course, adding any new functionality, I mean, fixing bug even, it's nearly too impossible because fixing one bug will introduce at least 10 other bugs. Okay, that's how it become 10,000 lines, by the way. Sorry, 30,000. So, in order to accommodate more features, it need internal structure like this. Okay. So, but does the test mention anything about the internal structure in this example? It didn't mention anything. Although the test is not big, but you see it doesn't have any reference to the internal structure. It tests everything just from one external entry. I gave you this piece of code and figure out what is the cyclomatic complexity. You don't need to assert everything at the end, but you only assert the things you care. So this is separating the behavior from the structure. Unfortunately, that is not common. I don't know I should tell you that, tell you this. There is a chance if you don't ever tell you might never know, right? So that you will never do it the wrong way. Unlikely, because people will still teach you. And then remember, run, okay, as quick you can. There is a tendency to map your test to your solution. So, like, you have these parts, right? Now, testing it from end to end is so complicated. Why not just test part of your solution? Okay? Then it will be much easier to test. Okay? And you know what? Some people even argue when the test fails, it's easier to change. But then you're coupling your behavior too tightly with your structure. The test is here to enable you from changing the structure. Actually, I'm not proud. Actually, I'm shameful for until today, for the design or the structure I made. But luckily, my tests doesn't depend on those structures. So whenever I dislike my structure or I figure out it doesn't support the new idea, I just go and change it, okay, which is called refactoring. Okay, I just change it. I don't need to change anything in my test because my test just makes sure my code is still performing my assumption for my code is still there. Okay. So mapping the automated test to your structure is wrong. Then there comes this thing. Let me try. I don't want to pollute your knowledge because I think this is probably important for you. If necessary, forget about this actively after I share. Okay, there's something fundamentally wrong about what is a unit test. Okay, what is a unit test? Now, where should I start even? So unit test, the well accepted or commonly accepted definition is a unit test tests a small unit of your code. This is a code and a test. A unit test tests a small unit of your solution. Okay, what is a small unit? Could be a class, could be a function, could be part of the function, right? Anyway, as small as possible, as shallow as possible. And for its dependency, you should mark them. That's the common understanding. However, I don't remember this part at all, like more than 20 years ago when I started to do unit testing. For me, at that moment, doing unit testing is about you can write a test and then run them repeatedly. Every time, they should produce the same result. And you put your assumptions into smaller units so that you can run them alone. You can run them again and again. You can run them in any sequence. They produce the same result. That was the unit. However, it's getting very hard to argue. These days, I think that was written already more than 20 years ago. There is a book called the X-unit pattern, which is like the Bible of unit testing. And in that book, the unit test is already defined as a test for a small unit. That's unfortunate. Okay, unfortunate. But however, especially in the AI age, okay, having the test duplicating your structure doesn't make any sense. Just you don't have to have the same truth repeated twice. So we want the so-called unit test just test from the external, and then keep everything in a black box. Just the unit to make sure that each test is a small test. Now, if you have an internal structure that is stable, you are confident that I'm not going to change it anyways, or I couldn't change it already, then it's okay for your test to depend on that. Okay, and if you have database, just use the real database. This is already 2025. Database is just memory. Okay, a unit test for me is just a small unit of test. Okay, so now you can forget about it. Okay, because don't ever share this with anybody, and don't use this concept when you trying to pass an interview. You will be rejected immediately because nobody defined it this way. Okay, so I compromised. I start to call it a small test. Okay, a small test is just small test. So the tests are very small. These are very small tests, right? Just each of them have only one line of code that's calling the production code and one assertion. The test is very small. How much code it is testing? It's testing as much as possible. Okay, code behind that. So you actually maximize the benefit from this test. And when you regret your design, you think, okay, I want to have a different layer. Okay, I want to have things running in parallel. Okay, in a thread, then you can just go and change it. You don't need to change your test at all. Summarize. What constitutes a good automated test? By the way, previously we call it automation. So each test focus on one small behavior. I'm trying to instill this to you. So distinguish behavior from structure, okay? And make sure your test is insensitive to structure change. How to become insensitive to structural change? Just not refer to them, okay? Python is an explicit language, so in Python it means you just don't import it, okay? And furthermore, you want your test to be able to support your automated, support your structural change. It might happen, okay, this is a bit advanced information. If you have some unit test here, which is testing behavior but at a lower level, okay, and now you regret that this three structure design. What do? You change your test to bubble up your test level to here. Okay, so now your test is still testing the same behavior but at a higher level. Now you can change it. Okay, or if it's not enough, you just keep bubbling up. Okay. Something doesn't exist here, not in the example, is so lizard is a very small application, just command line and with no much threading or process. But if you are building large product, chances are there's like mobile front end, the web front end, and Java backend, and use Kotlin and other weird stuff. And then there's also like services, microservices, a lot of stuff, right? It's not very common, by the way, in the industry. I'm not trying to lie. But it is possible for this very complicated and realistic product. You can still test it from the UI without mentioning any of the background service. By the way, you started all the services on your laptop, okay? When you are doing development, and run end-to-end tests, thousands of them, okay? And you still get the feedback within just a few minutes, okay? That is possible. But it is possible, doesn't mean it's easy. It's not easy, it's very, very hard. This is probably the top tier of programming job. Okay, it's not a testing job. It's the most difficult programming job. Let's say, which one is harder? Building the software or testing it? I mean, test it automatically. Which one is harder? Testing it is harder, right? Building the software is not as hard as test it automatically. If you try your best to build a software, what does it imply? It means it implies you won't be capable of testing it, right? Because it's harder than building it. If you already try your best to build the software, you won't be capable of testing it. So better, what you can do is try your best to test it, okay? And then only build what you can test. Of course, if you're not a professional, that doesn't really matter very much. Or if you don't want to build something that matters and that can continue, it's not a big deal. Yeah. Okay, so I shared two things already. Okay, one is about the automation, and the other is about how to do it properly. Focus on the behavior, be insensitive to the structure. Next thing I want to just talk very, very briefly about vibe coding. So my understanding of this trendy thing they call vibe coding is this 2 or 3 parts. The first part is about accumulating the context. What's in the context? Okay. So let's say if the product already exists, so the context is all the source code and all the document you provide, you want AI to read, okay? Plus your requirement, your prompt, what you want AI to do, okay? So I'm not trying to sell you a tool, by the way. This is called Cursor, so I use it frequently these days. And by the way, this is called an editor. This is where programmers used to work. They do not work here anymore. Where do they work? They work here. This is a chat. This is a chat. You talk to AI. In Japanese, they call it AI sama. And you beg AI to please do this for me. Okay. So then AI already know have the access to all your source code. Okay. It will pick them into the context selectively, and plus your begging, okay, or prompt they call it, okay, that make up the context, and then is the generate. Generate is automatic, done by AI. You need to pay to get it. The more you pay, the better result you get. Okay. Which is literally make a huge difference. Okay, if you heard people complain, you just tell them you're not paying enough. And also, there's other things called MCP. If you're not paying attention, MCP is a big deal recently that supply more content, and then it produce this boop result. It's called generative AI, right? To generate the result. After that, the story is over. So you got the result, and then a human, okay, will pick it up and do the thing manually and check whether this is what they want. If this is not, they will send more information or continue the chat to ask AI to produce more. Okay, so it starts the loop. I mean, does it work? I think it has been creating more harm. I mean, for an amateur to play with creating something new, experiment, it works really good. And you can use it for professional work also. It can save you a lot of time. But it gives you a lot of non-quality stuff. So in reality, it creates more harm. Although it has the potential to help, but in reality, it creates much more harm than just not using AI tool at all. So this is unfortunate, but very limited. There is an opportunity, though. So after you provide the context and the generator, in the context, you ask AI also to focus on automation. Means please use automated tests to define the problem, okay? Or define the problem first, okay? I don't want to predict the future, but if you heard the test-driven development, I mean, previously, I think the AI tools they don't focus on that. Even if you ask it to do test first, it won't do it. These days, if you ask the AI to write automated test to define the problem, run it to see it fail first, it will just do it. Okay, if you pay enough. So you ask it to focus on automation, okay? It will generate, hopefully test and probably a solution. I don't want to emphasize that you have to do test first. You can do it together. And then you get this automation in the loop, which means AI will run the test. Also compile, do linting, and also run the automated test. By the way, that means you need to have an infrastructure that support to running the test in a very complicated environment. And then the automation will produce some result. For example, whether all the tests and the new test pass or not. Did you break any test? If you break anything, what is the assertions? What is the log? What are some of the interim result? So these will do this reorient, meaning we are enriching the context. So because now the result will give a dynamic feedback to the AI system, which enrich the context so that the loop can continue without your engagement. So just one prompt, you wait for 15 minutes to browse your phone on TikTok, and then 15 minutes later, the entire problem is solved. Okay, I'm not trying to suggest that this will solve all the problem from end to end. I'm just trying to say this will push this automated loop much further. Previously, you can use it to go, the AI tool can help you to go 10 meters. Now, if you introduce this dynamic factor, it can go maybe 10 times further. And you have a chance to build something much stronger because now you have preserved your knowledge using the automation. Summarize, okay? To bring automation and good test automation to AI augmented software development. So I need to make a disclaimer, okay? So what I shared is just something that is like save you a few keystrokes. That's all. There's nothing more fancy than that, okay? It's not essential. There's no essential change to the software making process, okay? As I mentioned, in reality, if you look at the companies these days, they use AI tools to create. I mean, I'm only talking about programmer. I shared in the very beginning. I only know a little bit about writing software. I don't know anything else. So I'm not talking about AI in general. I'm just talking about AI programming tools. So people use AI programming tools to create much more harm than benefit. So what I shared how to use AI is because it's the right thing. So it doesn't matter if it's AI or I. It's the same thing. Right thing you should do. Okay. Conclusion: how to keep my code fresh? I've shared 3 aspects. One. If you want to be a professional, focus on automation rather than automation. Second, your automated test should focus on the behavior, be insensitive to the structural change, which is the right thing. The first one is doing the right thing. The first one is about doing the right thing. The second one is doing it right away. And then there's a chance to try it with AI. And that's it. Yeah. Oh, that's a very hard question. We are a group of, like, we have 4 people in Singapore. We do consulting. I'm a programmer as well, but we also do, we help a large organization to do software development from management to code writing. Yep. Yeah. Thanks for the question. Go ahead.
When you were working in especially like larger companies, did you ever struggle with like making your test item potent so you can like run it as many times as you need, or like mocking a certain feature?
Oh, don't mock. Don't mock. Don't mock. You don't want to mock. You want to test the real thing. Yeah. I hate to say it here. Mocking is like masturbation. Don't do that. I mean, you can do that, but just don't be proud of it. So my point is, when you are, I hope most of you understand what is mocking. Mocking is mocking structure or behavior. I mean, the people who promote the mocking trying to convince you you are mocking the behavior of it. No, that's not true. You are mocking the structure, mocking the interface. The interface is a structure. So mocking, especially mocking your own code, okay, is making sure the design cannot be changed. And it has no behavior at all, because the behavior is mocked. Yeah. So mock only when you have to. Yeah. Because there will be situation that you are doing unit tests, and then your code is calling some network service, and then there's no better option than just mock it. Yeah. And when you mock, mock the external things. Don't mock your internal things, which is, by the way, against the common recommendation. Thanks. Very good. Very good question. It actually there's no difference between this big change and small change. Okay. So just remember, never create a parallel system. Okay. So always from point A to point B, you can always plan like from 1 or 2 to 2,000, 20,000 small commits, and in every step. It's just a small change. You keep running your tests and getting feedback. So you can, I think I started by, I don't remember, but the code is running on a Python 2, and then I start to build a new test for Python 3 and gradually migrate. But anyways, during, I think it's in the history. If you're interested, you can find it. It happened because when I created Lizard, Git is not invented yet. So I think it's 2012 I migrate the project from SVN to Git, to GitHub, and 2012 Python 3 is not mainstream yet, right? Yeah. So I think it must be in the commit history. Sorry.
In your experience, is it a good idea to use AI for text generation? How well does AI work?
I have the feeling, so I have to confess, I do it. Okay, but I have a feeling it's not a good idea because tests should be quite essential stuff. So the test I shared is unit test, but I also have some other form of tests. Let me see. So, for example, yeah, go ahead. Yeah. Oh. Let me. Let me find. So this is also a test. This is also a test. I mean, in my definition of small test, this is also a small test. Given I log in as some person, I have a valid MCP token, I connect to MCP client. So blah blah. This is just like a human natural language, but this is also automated test. Like if you ask AI to write this kind of test, it's kind of probably not a good idea. Maybe I should be the one writing a test like this, and then ask AI to just automate it. Yeah. So I think probably tests should be the essential thing people write. Yeah. So let me, I think you're confused, right? My confession is I'm doing it, okay? Because there's still a lot of trivial work when you are writing test. So I do it, but I have the feeling, my gut feeling is I shouldn't do that. I should write the test manually by myself to define the problem at a high level, and then AI provide the solution. And also the test, automating the test. Yeah. Because to automate it, you also need some infrastructure. Yeah. Yeah.
All right, thank you so much.
Thank you.